Hello again. For those that decided to watch my video on rules, that's great. Um, I'm I've decided I'm only gonna go over the three rules that I've learned. The constant, well, technically four: constant rule, the constant multiple rule, the power rule, and the sum and difference rule. And these are gonna make your lives much easier. And I'm gonna try and go over this quickly because my last video was really, really long. Well, multiple parts that total to be really long. And so you have constant rule. And if you look this up, you'll find like, okay, so the constant rule here states that f of the derivative of some number, so the derivative of 10 or the derivative of -3, the derivative of the square root of 5 plus 2, or not 5 plus 2, yeah, 5 plus 2, whatever that is, that's going to be some value, and it's going to be some number, and whatever number you plug in here, that equals 0. And why is that? It's because if y equals a number, y equals 3, well, let me show you the graph. Y equals 3 on here. Oh, gotta take those off from the last video. And go back to home. Zoom out. Y equals 3 is just a horizontal line. And what's the slope on 3? 0. The slope is horizontal, so there is no slope. And that's why the derivative of that is 0, because the slope of the tangent line at any point on that graph is going to be 0 because it's horizontal. So that's an easy rule. So whenever you see a number, you can make it 0. The derivative of that is 0. And you say, well, we don't encounter that very often. So why is that important? Well, it's important because in the next step, it gets much easier. You have you get an arsenal of tools to be able to work with functions. And so, like I said, I'm not going to cover all of them because there's like 5 or 6 rules. I'm only going to cover 4. And this one was easy. So, you know, the derivative of 10 is 0. The derivative of 3 is 0. The derivative of square root of pi, and pi, remember, pi is just a number, 3.1415926 ... equals 0, because it's just a number. So yeah, making sure that my aspect ratio, or not my aspect ratio, the orientation of my phone is correct. I really hope I did that with the other videos. If I didn't, then I have a world of pain. Okay. Next rule. Power rule. This one is going to simplify your life a lot. Each rule I'm going to tell you is going to simplify your life even more. Oh, just kidding, not power rule. We're going to go constant multiple rule. That's why I keep saying 3 and then correcting myself and saying 4, because I keep forgetting to put it. As you see, I've written the rules down, and I put the constant multiple rule after I had written the other 3, and I was like, oh, that's a rule. So the constant multiple rule is f prime of some number x. We'll say, what letter haven't I used yet? We'll say k. So f of k, where k is a constant, k of x simply become, you take the k and move it outside, and it becomes k times the derivative of x. And this is very simple. Whenever you have the derivative of x, is just, so let me write a rule up to the side. I don't know the name of this rule. Something rule. Whereas f prime of x, and I'm not saying like the function f of x, the derivative of that. I'm saying the derivative of the variable x equals 1. Always. I don't know why that's so, but that's a rule. Just remember that. You could ask someone like, if you're on the GroupMe chat for this class, Sam Swee, he's really good at, I think that's how you pronounce his name. If I'm butchering it, please forgive me. You can tell me how to pronounce it later. But he's really, really good at math. He says it comes really naturally to him, and he's offered to help those who are willing to work hard to learn. And so, you might be able to ask him. He'll probably know the answer to that. The teacher will definitely know the answer, though she might confuse you. But, you could find it on the internet. So, back to the constant multiple rule. So that's just k times f prime of x, which is 1. Back to this. So let's say you have f prime of 3x squared. Well, how do you figure that out? Well, you take the 3 and you move it out here. There's no big formula to plug it into or anything like that. You move it out there. And that becomes 3 times the derivative of x squared. Well, what's the derivative of x squared? Well, we're going to cover that in the power rule. So that's easy. You just pull, if it's a coefficient, you just pull it out and put it there. So the power rule, this is making our life even more easier. F of the derivative of x squared. Well, what is that? So this, or let's call that n. Instead of x squared, we'll call x to the n power equals, you take this out and you put it beside here, the derivative thing goes away. That just becomes x, or n, times x to the n minus 1 power. And it sounds weird, but it's actually simple. And it's simpler when you look at something like x squared, for instance. So f prime of x squared becomes 2 times x to the 2 minus 1, because 2 is n, 2 minus 1 power, which equals 2 times x to the first, which equals 2x. And that's great. And you can see the derivative of x squared. We did that in one of my previous videos up here. Did this whole long process. Look at all that big process, and we got down to 2x. And here, instead of using that big 4-step process, I did it in like less than a minute. So this is powerful. Power rule. Okay. So I've done the constant rule, constant multiple rule, power rule, and the last rule I'm gonna combine. They're actually 2 different rules. I'm combining them. F prime of, and when you look in a textbook, you'll see like f prime of, or let's say like f of x plus or minus g of x, and you'll say that equals f prime of f of x plus or minus f prime of g of x. And that's just, and they put the functions in there. I think it's a little confusing to do that. I'm just going to say, for my definition, f prime of a, and a can be some function, it can be some variable, it can be some, like, it's basically any term. Any terms that are separated by pluses or minuses, we'll call one of those a, and we'll call another term b. And you can have as many of these as you want. You could have plus or minus c. But the idea is that that becomes f prime of a plus or minus f prime of b. And you've got, so let's put something in here. Let's say you're asked to find f prime of x squared plus y plus 3x, and so we're going to use our rules here of plus 1. So you've got this big polynomial here. It's really messy, I'm sorry. 11 minutes, come on. It's gonna take forever. Okay, so we've got f prime of x squared plus 3x minus 1. We'll do that. So that we have a plus and a minus there, so we simply say that equals f prime of x squared plus f, because the plus is carried, f prime of 3x, that's the other term, and then you've got minus, because that minus goes down there, f prime of 1. Now you've got a couple rules here, quite a few. So the first one you can think of is, well, this one's easiest. F prime of 1 is 0, right? Because of our constant rule here. F of any number, f prime of any number is 0. Because the slope is 0. I just figured out what why this rule works. It's because the function y equals x is just a line that goes up like this, and so your slope is 1 for every one x you have 1 y. It's the same. So that's why. Yeah, I figured it out. I'm smart. I can has math. So you have this one is simpler. So minus 0, and that'll just, we can just forget that exists, because minus 0 is unnecessary. I'm just writing it out so that you know what I did. So this one, we're going to use that constant multiple rule, or like the 3x squared, we're taking it out. So that becomes 3 times the derivative of f of x, and then our question mark rule over here says that f prime of x equals 1. So f prime, 3 times f prime of x is the same as 3 times 1, which is 3. And then plus f of x squared is, we bring the 2 out and then make the f disappear, and that becomes 2x. You know that because we did that in several problems before that. So 2x plus 3 times f of x is 2x plus 3 times 1, and that's 2x plus 3. 2x plus 3, and there's your derivative. Woohoo! And that can be used to find the slope at any of the tangent line at any point on the graph. So x, I'm going to pause it and graph it for you so you can see that it works, and it's correct. Okay, here's the graph of our function, and I picked a point for convenience. I've used nice numbers. I picked a y-intercept, which is conveniently 0, -1. Or no, that's the x-intercept, sorry. No, it is the y-intercept. Okay, that's the y-intercept, which is x equals 0, y equals -1, and I'm going to plug it in to our formula here to get m, which is our slope of our tangent line at that point. So it becomes 2x plus 3. So x is 0, So 2 times 0 plus 3 equals 0 plus 3, which is 3. So 3 equals m. And that is the slope of our line at that point. So we have y equals -1. We have x equals 0. We have m equals 3, and we need to find b. So I'll do this quick. I need to go to bed. And my wife definitely wants to go to bed. Okay. So y equals m of x plus b becomes -1, yeah, equals 3 times 0 plus b, which equals 0 plus b, which is -1, equals b, which is -1. And so you have y equals 3x minus 1, because that's what b is. So you plot this on the graph, and it'll be our tangent line. Y equals 3x minus 1. Look at that! See that? See, there's our tangent line at that point. And it intersects the graph at that point right there. And there you go, ladies and gentlemen. That is how, that is how you use these fancy rules to make our lives so much easier. Alright, bye guys.